everybody, let us discuss on the existence of inverse functions. If a function f has an inverse, then it must assign distinct outputs to distinct inputs. For example, f of x is equal to x squared. Let x is 2 and x is negative 2. F of 2 is 4 and f of negative 2 is 4. This means f inverse at 4 is 2 and f inverse at 4 is negative 2. This is impossible because inverse functions are unique for every function. This checks out that f of x has not an inverse function. The other way to check that f of x has an inverse or not is f of x is equal to x squared, y is equal to x squared, then x is plus or minus on the radical y. This doesn't express x as a single function of y. This checks out that again f of x has not an inverse. So a function has an inverse if and only if it is a one-to-one, short and precisely. We call that function invertible because it has an inverse. Then when is a function be invertible? If it is a one-to-one function, if and only. One-to-one means f of x1 is not equal to f of x2 whenever x1 is not equal to with x2. For example, y is equal to x cubed is an invertible. If we substitute two different values in this function, our result will be different. That is, this function assigns distinct outputs for distinct inputs. Then it is invertible. For example, another example, y is equal to x to the power of 4. This has not an inverse, or which is not invertible, because it doesn't assign distinct outputs to distinct inputs. The other types of functions which are invertible are increasing and decreasing functions. Increasing functions are f of x1 less than f of x2 whenever x1 less than x2. For example, y is equal to x, y is equal to the power of x are generally increasing functions. The next decreasing functions, f of x1 is greater than f of x2 whenever x1 less than x2. This is for decreasing function. For example, y is equal to negative x, y is equal to negative x cubed, y is equal to the power of negative x. These all are decreasing functions. Generally, increasing and decreasing functions have inverses or are invertible. This is all about the existence of inverse functions. On the next lecture, let us discuss on graphs of inverse functions in the horizontal line test. If f has an inverse, then the graph of y is equal to f of x and y is equal to f inverse at x are reflections of one another about the line y is equal to x. That is, each graph is the mirror image of the other with respect to that line, or the line y is equal to x. Examples of the graph y is equal to 2x. A linear function crosses the origin, looks like this. And its inverse, y is equal to 1 over 2x. Again, a linear function which crosses the origin, looks like this. These two graphs are mirror images on the line y is equal to x. The next, y is equal to x cubed, a curve which crosses the origin like this. And its inverse, y is equal to x to the power of 1 over 3. Again, a curve which crosses the origin like this. Again, these two graphs are mirror images of each other with the line y is equal to x. Let us apply horizontal line test to check out whether these functions are inverses of each other or not, or these functions has inverses or not. On the first graph, y is equal to x. If we draw a horizontal line, it touches only at one point. This means this function assigns only a distinct values or outputs to distinct inputs. For the next graph, y is equal to x cubed. If we draw a horizontal line, again it touches only at one point. What if we draw on the graph y is equal to x squared? If we draw a horizontal line, it touches the graph twice. This says that this function is not invertible, which means it touches the graph at 2 points, means this function assigns the same values for different inputs. The next point is restricting domains for invertibility. In order to get inverse functions, we are going to restrict some domains on a function. For example, on the function of f of x, which is equal to x squared, first of all, this function is not invertible. Then what if we restrict the domain as x greater than or equal to 0 and x less than or equal to 0? When we limit or when we restrict the domain as x greater than or equal to 0, the graph only looks on the right part, or we focus on only the right part of the graph. Then it becomes invertible. When we decide the domain as x less than or equal to 0, we focus only on the left part or the left side of the graph, which becomes invertible. This is about a restriction of domain. If only draw a horizontal line on the right part of the graph and on the left part of the graph, this horizontal line touch only the graph at one point. This checks out that when we restrict the domains of a function which is not invertible, it will become invertible. This is all about graphs, horizontal line test, and restricting of domains. Totally, this is all about inverse functions. On the next lecture, we will see another topic. Until then, have a nice time and thank you for watching.